Okay, dot products. What is a dot product? Well, you want something like multiplication for vectors, but it's not really, it comes out a little different. Suppose U is equal to AI plus BJ, and V is equal to CI plus DJ. By definition, U dot V, and this is this little times thing, it's called dot, is the norm of U. And okay, so sometimes I'm putting these little arrows on top, sometimes I'm not. It's just how lazy I am. There always should be these little arrows or some indication that they're vectors. I'll try and be better about that. But if I forget to, don't worry about it. So U dot V is called, it's the norm of U times the norm of V times the cosine of theta, where theta is the angle between them. This is also the same as this. It is AI plus BJ times CI plus DJ. I'm going to FOIL this out. This is AC times I dot I, right? Plus, okay, so what did I do? I did that. Now let's do this. This is plus AD I dot J plus BC, sure, why not? BC J dot I and plus BD J dot J. Well, what are these? These I's and J's, we know that the norm of I equals the norm of J is 1. And also, think about this. What is I? I is on this direction. J is here. The angle between them is 90 degrees. The angle between I and itself is 0. So this is AC times the norm of I, cosine 0, 1 times 1 times 1. This is just AC. Plus AD I dot J. Well, this is going to be the norm of I, which is 1, times the norm of J, which is 1, times the cosine of pi over 2. Cosine of pi over 2 is 0. By it goes away. It's done. J dot I similarly is 0. This term is done. J dot J. So this is going to be B D, the norm of J, which is 1 times 1 times the cosine of 0. And the reason why the angle is 0 is because it's the angle between these two vectors, which is they're parallel. So there is no angle. It's 0. So this is 1, and this is what it comes to be. Now, for those of you who don't really care much about the theoretical and really just want to kick some butt on some examinage, I'll show you all you really have to know about how to make this work. Although that definition you're definitely going to have to know. But it's really, really fantastically easy. Okay, so I had some other things. I'll make up one quickie. So let's let U equal 1, 2, and V is equal to 3, 4. Then U dot V is equal to 1, 2, dot 3, 4. You don't have to write this. I'm just trying to be really precise. This is 1 times 3 plus 2 times 4. This is 11. So notice, dot product is not a vector. This is a scalar. This is a number. It has no direction anymore. When you dot something, you're taking vectors and you're turning it into a number. Okay, and specifically, once again, by definition, U dot V is equal to the norm of U times the norm of V times the cosine of the angle between them. So this is the angle between them. Enough. Some things that you need to know about dot products that are important. They behave very, very well. U dot with itself is just the norm of U squared, right? Maybe I should show you this. Why is this true? Well, so let U equal A and B. Then U dot U is equal to AB dot AB. Once again, I'm putting in this extra step just so you can really see it. It's going to be this times this. This is A times A is A squared plus B squared. Well, this is the square root of A squared plus B squared squared. This is the norm of U squared. Groovy. More nice stuff. U dot V equals V dot U. It commutes just like regular multiplication. A times B is B times A. It's transitive in this sense, so if we have U times V plus W, this is, times would be a mistake. You need to dot it. Times doesn't make sense in vectors because they're not numbers. So this is, it distributes. It hits here and it hits there with the dot. So this is U dot V plus U dot W. If K is some scalar, so K is a number, right? So K times U dot V is the same thing as K times U dot V, which is the same thing as U dot K times V. So you can move numbers in and out through this. Also, another thing that's really kind of weird, this always freaked me out when I first learned about this, 0 dot U is equal to 0. This is the 0 vector. It has norm 0, and it doesn't really point anywhere. This is the 0 number. It's very, very subtle what the difference is between these things. It's pretty cool, okay? This, you need to define a vector space. And you actually need this to define a field. So don't worry about it, is what will happen. When you get to linear algebra by your second or third year, depending on where you are in college, when you do linear algebra, then noticing the difference between U as a 0 as a vector and 0 as a number will be different. And important. Okay, Mr. Producer, where are we for time?
2 minutes.
2 minutes. Okay, so once again, by definition, we know that U dot V is equal to the norm of U times the norm of V times the cosine of the angle theta, which lies between them. That means we can define the angle between them. So here's the deal. Here's U, here is V, and here's some theta. Well, what is this theta? Well, if we have enough information, and of course, assuming that these are not the 0 vector. Okay, so the truth is the 0 vector is a big deal to make sure that you have a proper basis for the vector field, which is really beyond the scope of this class. And outside of that, it doesn't really show up very much, right? Okay, so, and actually, let me be really clear here. It's overkill, but I wasn't being as accurate as I should. What I'm saying is that neither of these are the 0 vector. And that means that neither of these are, so this is not 0 bar. And that means that neither of these are 0 the number. Right? These are vectors. When you dot them, these are numbers. Why did I do that? Because cosine of theta is this thing. And my producer has told me that we will be right back.